announcements. Okay. The first of these announcements is, I think I told y'all last week that stand by, there could be a day when I have to do biology interviews. Sunday morning, the dean sent an email saying the interviews were going to be yesterday. So she sent on a Sunday morning. It was just happenstance. I happened to check the email Sunday afternoon. Most Sundays I don't spend doing emails, but it seems like a rainstorm came up or something, so I just started checking emails, and sure enough, I saw we had interviews. So I was out all day yesterday from 7:30 in the morning until close to 5, and I left Birmingham campus, came back here, and taught my 5:30 class. So I missed my Calculus 1, Calculus 2, and Physics 1 classes yesterday because they scheduled them for Monday. I would have hated for them to miss the Tuesday, but we've already missed 3 Mondays so far. That's 4. Those students have had an 8-week summer term now because Memorial Day was a Monday. I had to be in New Orleans for a Monday because the vice president wanted to go to a wedding and wouldn't do the one in Atlanta, which was a Friday, Saturday. I wouldn't have missed any classes at all. That's the one I requested that we do. Ignored that. And then the governor gave us a Monday off, so that was 3 Mondays, and then I had to miss last Monday too, yesterday too. So far we've only missed 2 Tuesdays when I was in New Orleans and 4th of July. So it would have been better. I would have hated to miss this class, but it would have been better for the other students. But anyway, that's over the bridge. So those are done. I'm not going to have to do any more interviews. Okay. Now, number 2. Next Tuesday, I have a doctor's appointment. Okay, I think I told you early in the term, my hematologist only sees patients on Tuesday mornings. Only on Tuesday mornings. I can't schedule it for Friday or any other time that's convenient. Only on Tuesday mornings. Next Tuesday's appointment is at 8:40, so it won't bother this class at all. Okay, I was afraid it was going to be 11:40, and that would bother this class. But it's 8:40, but it's going to bother my differential equations class because I have to be there for labs at 7:40, so no way I'll be here at 8 o'clock. And with it being at 8:40, I can't be through with it any earlier than 9, I don't think. I doubt if I'll be through as early as 9. But if I am, it's still 45 minutes to get to campus, 30 to 45 to get to campus. So that's 9:30, 9:45 for a 9:50 class ending. So we're not going to have class then. So what we did today, starting today, we did an hour or 55 minutes extra at the end of class. And then we'll do that again on Thursday. So my office hours normally are 10 to 12 on Tuesday and Thursday. Today they were 11 to 12, and Thursday they'll be 11 to 12. So I'm going to make up that class I'm going to miss next Tuesday with them by doing the class longer. I did it today. I'll do it again Thursday. So don't look for me down in my office from 10 to 11 because I'll be up here making up that class. But then next week I'll be back to normal. Okay? Today I'm going to have to leave right at 5:15. A lot of Tuesdays and Thursdays I stay later. I can't. I've got a meeting in Birmingham that actually starts at 5:15, but I told them I'd be late, so I will be there as soon as I can. So I'll leave at 5:15 today. Okay, I can't think of anything else. Let me mark this. Lab number 4, which was the planetarium trip. Ricky got a 25. Brian got a 25. And James got a 25. Okay. Done. Okay, any other questions before we get going on this? Today, actually we're supposed to be starting right now, the Chapter 20 test, aren't we? Or did we have not?
Yeah, Chapter 20.
I mean, not 20, 18. Were we supposed to have that today? Okay. If y'all aren't ready for it, we'll just have it next time because only 2 of you here. We'll just wait, have it the last 30 minutes on Thursday. Because we did finish 18 last time, right? Okay, so what we'll do is we'll continue in 19. We won't get very far today, so next Thursday we'll start with 19. If we finish 19 on time, then by 1 o'clock, is that right? 12 to 1. I doubt if we will, but if we do, then we'll go on and have the lab from 1 to 3, and then have the test on 18, after that. So plan to do that next time, okay? All right. Yes, we did this slide last time, and the next slide builds on it. So just as a reminder, stresses are the forces, strains are a resultant of that force, okay? So let's now first look at stress and deformation. And this is almost strength, okay? Possible material responses to stress, those are strain, okay? And we did this on the last one. We're going to do it in a little more detail now. Number one, there could be no change. For instance, I think I did this last time, I'm going to push on that desk. I'm exerting a force and stress on the desk. It's not noticing a thing. My finger notices something, the desk doesn't notice a thing. So that stress produced absolutely no strain on the desk. None. And that happens a lot too. Okay? You can push on a rock, you can do all sorts of things, and if it doesn't change, that's one potential response, material response. But you also have another, and this could be an elastic change with recovery. Now, I might argue with you a little bit that really I am compressing the outer couple of molecules of that wood just a little bit, but as soon as I release the pressure, it comes right back.
I noticed when you put your hand on the board too.
Yeah, okay, yeah, you've seen that. Okay, there. Stress, but now no, that's elastic change with recovery. I don't go through the board, but it comes right back. Very good example. Elastic change with recovery comes right back like it was before. Okay? The third type is a plastic change with no recovery. Okay? Let's just imagine. Can't think of. Well, I could do this. If I took a piece of paper and wadded it up and then released it, it stays wadded. That's plastic change with no recovery. Okay? It stays wadded. Okay? Or the other would be, I'm not going to do this, but I think you could imagine that I did. What if I took this and put a stress on it and put a stress on it? I could put a little stress release and it comes back elastic with recovery. I don't think, unless I heated this while I was bending it, then I'd warp it. That would be a plastic change with no recovery. But if I did a real sudden bend of this, I could actually fracture this, I think. I believe I could. Okay? That would be breaking from the pressure. And we call that fracture. Okay? These are all things that rocks can do. No change, give, but come back, elastic change with recovery, or plastic change, bending, wadding, wrinkling, with no recovery. Think. Again, I remember the old Saturn commercials about the kid playing bounce ball or something like that, and the ball hit the door of the Saturn and it popped back. So that was elastic change with recovery. But throw a baseball real hard into that, you're going to have a dented car fender. That would be a plastic change with no recovery. Or if that was a fiberglass body like they used to have on the old vets, throw a ball at it, it fractures, breaking with the pressure. The rocks do the same thing. Now, what about the rock determines which of these happens? What rock variables do we have that determine which of these happen? Number one is the nature of the rock. Okay? If you have a rock that has very strong crystal structure, the odds are you're going to have no change. Okay? Remember when you did the lab for the last chapter, the fracture and cleavage. Okay? Some of those were very hard rock and they'd have no fracture or cleavage. Some of them were very brittle rock and they would fracture very easily. And some of them, okay. So the nature of the rock, that would determine which one of these is going to happen. But then, and like I said with this, if you increase the temperature of the rock, then the odds are you're going to go to plastic change, possibly with no recovery. Might do a little bit of elastic, but if the hotter the rock, the more likely it is to have a plastic change with no recovery. Now, where would the heat come from? Way down deep. The magma is almost, it's hot, it's melted rock. The mantle is usually pretty hot because it's so close to the magma. So yeah, you could easily have temperature. On the other hand, if you had very frigid temperatures, you could have much more breakage with less elastic with recovery. That's just like I was trying to think of a good example when it's not a good example. But I've heard it said, and I don't want you to go home and try this at home, but if you did happen to have a bottle of liquid nitrogen at the house, and you stuck your finger in it, and you did that, there goes your finger. It just immediately freezes it to ice, and then you have, don't do that. That's just a dumb example. Okay. So temperature of the rock will also determine, the higher the temperature, more likely to have plastic. The lower the temperature, you might have either no change, elastic, or actually, if it's very low, breaking with the pressure. The speed of the stress application, I sort of gave it here. If I do this very slowly, I get a little bit of elastic, let it come back. If I did it real quickly, it's going to fracture. So the speed of the stress application, that's going to make a difference. And then the other is the confining pressure. Okay? What does that mean? What if you have a whole bunch of overburden up on top of it? In other words, layer on layer on layer of stuff above it. Then you have some pressure from below it. So it's confined, but you have a little bit of a reduction in pressure somewhere, then that's where it's going to give. Especially if you combine that with temperature, then you could have this bending of the rock, okay? Plastic change with no recovery, okay? The confining pressure might lead to no change. If just the pressure is there, but nowhere for it to go, it's going to be confined. But if a little bit, you could have elastic change with recovery. So the confining pressure combined with the others. Interplay produces observed rock structure. So you can look at some of the things. I love, drive my wife crazy sometimes, but I love to drive down the interstate and look at where they raise the road cuts through the mountains and just imagine, oh, look at that. There's a fracture there. There's a bending there, and you can pick those things out pretty well. Here are some graphs that show what we're talking about here. If you have a little bit of a stress with no reaction, that's always going to be around down here, that's usually happening, that's the no change. But if you have a little bit of the stress, but the strain, the result of that is just a little bit of strain, then when you release it, it goes right back to where it was. That's the straight part here or here, okay? Two different kinds of rock here, okay? That's elastic behavior. Anytime that line is pretty close to a straight line, that's elastic, okay? The plastic change is when you start having the bending, okay? You add more stress this way, and suddenly the strain takes on different shapes. That's plastic deformation, okay? The breaking from the pressure that could come at the end of the elastic, it could come at the end of plastic. It could also come, if it's a very brittle rock, after no change. There's no change for a while, and then suddenly it breaks. Okay, that could be. The rupture could come almost at any time, but that's what we mean. The straight line response here, that's elastic behavior. The curved line response, that's plastic deformation, and then where it finally just breaks and ruptures, that's your third.
Would a earthquake be an example?
Oh, absolutely. That's exactly what we're getting at. Okay? An earthquake is when there's been the pressure, and so far there's either no change, the rock is very hard and solid, and the pressure builds but not have any change, or the pressure builds and it has the elastic change that if the pressure does release, it just goes back and there's no problem. Even if it's plastic change, and maybe the heat is there and it's changing and bending, but it's not going to come back to the original shape. But where the earthquake is where there's the rupture. It could be here, it could be there, it could be here, anywhere. But that's when you've got the pressure, and then finally when it gets so much, something breaks. That's exactly the earthquake. Okay. Right on the money. That's where we're heading. So there's two types. Well, there's actually three types of strain. That is the result. Okay. This is, by the way, this one's on page 84. Actually, yeah. Now, two types of strain. I want to say three, but I'll get there when I get there. For right now, we'll say two. Folding, and then the next one will be faulting. The faulting is basically the plastic. You have changes in the shape without returning to the original shape. And this happens, it may happen in several types of rock, but it's most obvious in the sedimentary rocks. Because the sedimentary rocks are usually sedimented out in layers, one on top of the other on top of the other, and sometimes you can see those layers, sometimes you can see the interface of those layers. You can usually tell exactly where they are. Usually originate from flat sediment deposits, either by water or by sandstorms or whatever caused those deposits, you got them. The layers are usually fairly horizontal. Okay? Now, if that has built, and what were the two stages in that process? What was the process called? Making sedimentary rock? Okay, those are the two steps. What is that put together? That's called, it's the making of a rock. Rock, remember the term is lithification. Okay? The lithification of sedimentary rock, especially plastic sedimentary rocks, that would be the compression, like you said, pushing out the air and some of the water, and then cementation for when the water does finally evaporate away, the chemicals that are there dissolved, left there, they're holding the particles together. That's the cementation. Usually that happens in layers. Okay? Now, you've had this, it's happening, you've got more and more overburden, the rock is getting harder and harder, but then it gets down into the bedrock and maybe starts getting hot, or there's some sort of pressure from beneath, and now you have uneven pressure. Pressure coming up from below, overburden here, and that could result in folding. Bends in the layered bedrock result from the stress producing a plastic strain. Doesn't go back to the original horizontal layer, it stays folded. Widespread horizontal stress can produce domes or basins, either one. If the pressure is greater from below, it forms a dome. Frankly, I think Stone Mountain may be that. Have you ever been to Stone Mountain in Georgia? huge granite outcropping. Now that wasn't sedimentary, that was igneous, okay? But there must have been some bubble of magma came up underground and made a big granite outcropping there, and then the soil washed away from around it, left a big rock there on the mountain, okay? But this is talking more in terms of sedimentary rock, but you can still have those domes. Or, and this happens too, a lot of times those sedimentary rocks, especially if they're built on top of a weaker rock, such as limestone. And we have a lot of limestone underneath Alabama. A lot of limestone. Huntsville, mostly limestone underneath it. Clay Chalkville, I think, is mostly limestone. Probably a lot of Birmingham. I think there's a fair amount of granite here, and probably there too. But so you have this. But if you have limestone under here, and water starts dissolving the limestone away underneath the sedimentary rock, then you have a basin, okay? So it doesn't have to be upward pressure, it can be a downward pressure. The overburden is increase the pressure, yes.
Something like that created like a
Caldera? I believe so. I'm not as familiar with that. Is that in mountains?
It was like I guess like it's a caved-in volcano.
Yeah, okay, exactly. Okay, you're right. I couldn't remember exactly where I'd seen the term. Yeah.
Crater Lake
Is what?
Crater Lake.
Yeah, Crater Lake. Yeah, it's a caldera. Yeah, okay.
It was a national park in Oregon.
Very good. Yes, exactly. And part of that also is that when the magma solidifies, it shrinks. And so that's the other thing that causes that. So it doesn't have to always be, it's dissolved away, it can also be shrinking. Because when heated things, when they're hot, they swell, and when they shrink, when they cool, they sort of shrink. And that could cause part of that as well. So probably some of both. There are, I don't know if you've ever noticed this, but I grew up on a farm in Georgia, and there would be periodic, in fact, we had a couple of places in some of our fields where there'd just be a low-lying area that they called them Grady ponds, meaning in wet weather you had a little pond there, but when it dried out, it would be dry. It wouldn't be a 12-month pond. They called them Grady ponds. Well, when I took soils class at the University of Georgia, the professor said, well, that's because they were underlain by a chalk, which is a very soft limestone, and when it interacted with oxygen, it became carbon dioxide, and it disappeared, and the land settled, and that made the basins, and that made the Grady ponds, okay? So that could produce either the domes if the pressure's from below, or the basins if the pressure's from above. But you also have these arch-shaped structures. Like if you have a linear pressure, think of the Mid-Atlantic Rift, where the pressure is coming up in between the two plates, you form these arches. But that can happen also in sedimentary rock and also other types of rock. That's called an anticline. Now, how I remember that? A arch anticline. If, again, you have the settling out along the line, that's called the syncline. Settling, or cross shape. That's the syncline. Here's a couple pictures that will illustrate that. This would be a anticline, an arch-shaped structure. The older strata is here, and pressure has come up and pushed it upward, making these arches. Okay? Whereas on the other hand, if the older strata was down there and whatever was underneath it either washed away, oxidized away, or cooled and settled out, that would be called a syncline. The cross-shaped structure is a syncline. Okay? Basically the reverse of each other. Okay? Oh, they don't have the picture, do they? Maybe they do. Okay. Oh yeah, that's exactly the same wording here. Some new pictures. Now what you reckon this is? Any idea? I think that's part of the Grand Canyon. Okay? Lots of erosion. We'll talk about that in the next chapter. Yeah. But you can tell everything was layered horizontally. So this is mostly sedimentary rock. Those layers, everything is layered. So that was sedimentary rock, but it's been washed away. And frankly, sedimentary rock is usually more easily eroded by wind and water, so that's not at all unusual. Here probably is a granite outcropping, and it is weathered. So it stayed there, everything else weathered away. Pretty weird looking, huh? Okay, this used to be like that, but look what happened. This would be a anticline. This would be a syncline. Looks like maybe another one there too. So this is what we mean by folding. Your rock didn't break, it just was the plastic strain. Deformation. Changed the shape and didn't go back to the original. So this was no stresses or no result of the stresses, this distress. And the odds are there was a lot of heat under here at some time. And it's pushed this up and pushed it up in very amounts. Okay? So that's pretty much your folding. Here's another big example. This would be a syncline, anticline. Now, we're going to get to this later. This also has some faulting, which is cracking. But before it faulted, it was an anticline, a syncline. Look at the size of that. Where is that? The previous book had this. I think it may be here too, but it doesn't say. Okay. Let's see. Do I find that picture anywhere here? In the old book, I did have it, and it did. I think it was somewhere either in Canada or Montana or Colorado or somewhere. I think it was out west. I can't be absolutely certain, but I think it was out west. But look, I mean, here is a person. Those are cars. You know, look at the amount of pressure that must have happened, and this must be something that there's a lot of pressure that's forcing it up, because that was way underground when it did that, because it was under a lot of heat, and that has forced its way up. Okay, those are examples of folding of rock. Okay, this was at one time a dome. Okay, and you can tell it was a dome because the age of the rock around it are different layers. The oldest formation is here. Next oldest, and most recent is out here. There's been a lot of erosion here, but at one time that must have been a dome. This, I think, is, if I'm not mistaken, no, they don't have it in this, but I think in the old book that was called, I think it's Sundance. I'm not sure, but I remember Sundance. Butch Cassidy and the Sundance Kid, you know, what's the name of it? That movie, yeah. I think this is near Sundance Mountain. There's still some rise here, but you've had a lot of erosion around here. Because, again, sedimentary rock, when it fractures like this, when you get that pressure, then it's easily eroded away. But you do have the older rock in here, younger rock out here, and the younger rock is eroded. The older rock is sort of held in shape. I think that's Sundance Mountain. I'm not absolutely certain, but I believe it was. And that's somewhere in Colorado, I believe. Isn't that where the Sundance Film Festival is? Seems like it is. Okay. And I don't see the slide they indicated they wanted to go there. Now, the next is faulting. And I think we're out of time, aren't we? So we will pick up here next time. Okay, so we have faulting to go. We have earthquakes to go. We have origin of mountains to go, volcanic mountains, And that's pretty much it. If we can finish that in an hour, I don't know if we can, but if we can finish that in an hour, that will be 12 to 1. From 1 to 3, we'll have the lab. Wait.
This was the lab period passed out. That's the next level.
Okay, what's the name of it?
Experiment 43 density of big rocks.
Okay, we did that in class, didn't we? No, we didn't. That was what we were going to be doing today. Yeah, that was from the last chapter. That's what we're going to do today. We should have done that today. No, we didn't have time. 30 minutes is not enough time. So we'll do that next time probably from 1 to 3. And then from 3 to 3:30, we'll have the test on chapter 18. Now that one, yeah, I passed it out because I said you can start working on the questions. That's it, I remember now. There's only 10 points on the lab part. The other 15 points are the questions at the end of chapter 18. That's why I passed it out to you so you can start working on those, because guess what? Those are great ways to study for your tests, is to work on those questions. It's the, what do they call those questions? One's for further analysis, and the other is questions for thought and for further analysis. 16 questions for thought, 4 for further analysis. Any 15 or more of those 20 questions you can do. Okay. And we'll pick up next time. We didn't get very far today, but we only had less than 30 minutes. So we'll go an hour in chapter 19. We'll do 2 hours of lab. It won't take you 2 hours. You've got the rest of the lab right there. You can be working on that right now. And then we'll have 30 minutes worth of tests. And if we finish early, shucks, I guess I'll have to let you go home. But the lab is sort of interesting lab. I think you'll find it's our only wet lab. We actually will do something physically in the lab. We've done other things too, but we will actually do a lab this time, okay, in the traditional lab sense. Good deal. Thanks for being here. Thanks for coming back. And you did enjoy the planetarium?
Oh, yeah.
Good deal. All right. And we will see you on Thursday.
All right.
Okay.
I will see you.
Pretty sure.